Hello, and welcome to another session of Excel Programming for Clinicians with me, Dolotson Callum. In this session, we will take a look at how to work with arrays. Now, earlier in this series, I introduced you to some simple variables, and we have met a number of new variables and new data types along the way. Arrays are a special case of variable and allow us to work with not just one value, but a set of values. So we will look at why use arrays at all. We will then take a look at two types of arrays, the static array and the dynamic array. We will look at how to resize a dynamic array, and we'll look at how to work out the upper and lower bounds of our array. Next, we'll look at how to split a list into an array and how to join the items of an array back together into a list. After this, I will introduce you to the array function, following which we'll see how to convert an Excel range into an array object. We'll see how to delete items from a static array and how to delete items from a dynamic array, and we'll see that there's a difference when you do based on the type of array. Finally, I will give you an introduction to two-dimensional arrays. Okay, let's start by taking a look at why use arrays at all. Well, let's see what it would take to add some patients to our data tab if we didn't use arrays. Now, one way to do that would be, say we wanted to add 5 patients. One way would be to declare 5 variables. So let's do that. Let's declare a variable for patient 1, a string, and then we'll copy that and paste it 5 times to create 5 patients. Okay, not too painful, but still we've had to copy and paste and we're using the same type of code over and over again, but let's keep going. The next step would be to make sure our data tab is selected. So let's do this. Let's use the sheets object. Pass in the sheet name that we want and call the select method. Okay, so that makes sure our data sheet is now active. Now let's populate our variables. Now these variables could come from an import, for instance. Or it could be that we've asked the user to enter some information and we're just assigning those to variables. So I'm just populating my patient variables. Okay, we now have our 5 variables populated. Again, you can think that's not too painful, but what if we had, 20 patients or 30 or 50 or 100? So it starts to get to be a lot of work, but we've coded it without using array so far. So let's continue. Let's use range objects to populate our sheet. So I'm using the range object and I'm setting the value property to each patient. Okay, I can copy and paste that 5 times and just change the cell that I'm selecting and the patient. Okay, so it doesn't look too painful, but we've had to repeat the same type of code over and over again, but it works, and it's only 5 patients. So let's run this and see what we get. And as you can see, our sheet is selected and our data is populated. Next, let's take a look at static arrays. Static arrays are a type of array that is defined and fixed in size at the time you define it. That's why it's called static. In a moment, we'll take a look at dynamic arrays. But the static array has its size determined at the time you declare it, and then you can populate it and use it. Let's see how it works. To declare a static array, you declare a variable much as before, and you say what the data type is. But this time, instead of just declaring a variable on its own, you need to set the start and end size. So I want my variable to start at position 1 to position 5. This then, patient, is a static variable with 5 positions, position 1 to position 5. Let's see how we use this. Let's copy our patient list from before, paste it below. But this time we don't want to use the individual 5 variables. Instead, we want to use our static array variable. The way we use that is we assign the variable, but we say which position we're assigning the entry to. So in our static array, position 1 would be this patient. Position 2 will be this patient. Position 3, this patient. And position 4 will be this patient. And position 5 will be our final patient. So instead of declaring, as we did before, 5 different variables, now we're declaring a single variable with 5 positions, position 1 to position 5. It's still of type string, as our previous variables all were, but now it's a static array with 5 positions. So I can assign each of those positions a value. What's the benefit of this? Well, now I can loop through my array and use my array to write to Excel. Let's do this. Let's declare a counter variable, I as integer. Then I can do something like this. I can say for I equals 1 to 5, I can write some code and then I can say next I. So what do I want to do? I want to populate my data sheet. So let's use our sheet subject. Pass in the name of the sheet we want and call the select method before we enter our for loop. And in our for loop, all we need to do is say range and then say I and concatenate on our counter variable I. And set the value equal to our patient variable at whatever's at position I. Okay, so we've declared a static array variable with positions 1 to 5. We've populated each of those positions with a particular patient. We've selected the data sheet and we're for-nexting through positions 1 to 5 and grabbing the entry from our array and assigning it to the value property of a range object. And the range we're selecting is range A at row I. Okay, let's run the code and see what we get. And as before, it populates our data sheet. But this time we've used an array instead of declaring one variable per patient. Next, let's take a look at the dynamic array. Now, the static array is really useful, but it falls down when we don't know how many patients we're going to have, because you need to pre-declare the size of your array. Dynamic array allows us to start with an array of size 0 and then resize the array once we know how many patients we have. Let's take a look at how it works. To declare a dynamic array, we declare it as before, but this time in our brackets, we do not set a lower and upper number. We just declare an empty array. The fact that this array has been declared with empty brackets makes this a dynamic array. So at the point it's declared like this, it can't be used. Before we use it, we first need to set the lower and upper limits of this array. But that gives us an opportunity to first work out what the size of our array needs to be before we redeclare this array with a known size. So I'll first show you maybe an inefficient way that works, but it's not the best way of working out what the size of the array needs to be. And then we'll see how we improve on the code. So let's say our data is coming from an import. Let's declare a variable for the file name of the file we want to import. And let's use the application object get open file name method to get the file name. Let's also declare a variable for our free file. Remember, we need this to open a text file. Okay, with that in place, we can call the open method, pass in the file name, and say we want to open it for input. As file number. Let's also declare a variable to count how many patients we have. We'll set that to 0 to start with. And then we'll use a do loop to loop through our open file until we get to the end of file. So do until and loop, and inside our do loop, we'll write the code to count out the number of patients. Let's declare a variable for each patient name in our file. We'll then use a line method to get each line in our text file and insert that into our next line variable. Let's print that next line to the immediate window. And let's increment our patient count by 1. So what does this do? This loops through the file that we've just opened until it gets to the end of the file, and it counts the number of patients, essentially. So by the end of the loop, we know how many patients we have. So we can now close the file. And redeclare our patient variable, this time knowing how many patients we have. The way you redeclare is to use the keyword redim. Put in your patient variable, and then you say from 1 to patient count as string. So before, we declared our dynamic array without setting the lower and upper bounds. This time, we're redeclaring with a lower bound and an upper bound because now we know how many patients we have in our file. Okay, so we're going to reopen our file. So let's copy these 2 lines here and paste them below so we can reuse them. So we set our file number to the next free file, and then we open the file for input as the next free file number. We'll also need a counter variable, so let's declare that I as integer, and let's set I equal to 1. Before using my do until loop to loop through the file, I want to make sure I use my sheets object to select the file. With that in place, I'm now ready to write my do loop. I'll copy the do loop we used before. And the steps are the same, except this time, instead of writing to the debug window, I want to populate the ith position in my dynamic array with the next line. I'll then use that to write to Excel. and I remember to increment my I variable by 1. Finally, I'm ready to close. So let's take a look at what we've done. We've declared an array as dynamic, and we know it's dynamic because we haven't set a lower and upper bound, even though we've got the brackets there. We've asked the user to select a file, which we've put into our file name variable, and we've used free file to get the next file number. We've then opened the file, we've initialized our patient count as 0, and we've looped through the file, getting the next line and putting it into our next line variable. And each time we've printed that next line to the debug window. At the end of each loop, we've incremented our patient count by 1. Finally, we close the file. By the time we close the file, we know exactly how many patients we have. So we redeclare our dynamic array, this time with a lower bound of 1 and an upper bound of the patient count. We reset our file number to the next free file, and we reopen the file. We then use a counter variable, because we'll need that to write to Excel. We select the sheet we want to write to, and we loop through the file again. This time, each next line is assigned to the ith position in our dynamic array. We then extract the value in the ith position in our dynamic array, and we write that to Excel, remembering to increment I each time. We then finally close the file. Let's run the code and see what we get. We're asked to select a file, which we select, and our patients are populated. Notice that we didn't know how many patients we were going to get, but we were able to populate our file even though we didn't know the total number of patients. And that is the value of a dynamic array. Next, let's look at how we dynamically resize a dynamic array. So in our dynamic array example, we had to open the file twice in order to first work out what the size of our dynamic array needed to be, and then reopen it to actually copy the data. This time, let's see if we can do it without reopening the file twice. Let's copy some of these variables here because we'll need them. And let's reuse them in our dynamic array with reading preserve. So as before, we're asking the user to select the file and we're putting it into a file name variable. We're then getting the next free file number to use as our file name, and we're opening the file. Let's start with our patient count variable initialized to 0. And let's write our do until loop. So we want to loop until we get to the end of the file. As before, we want to get each line or input from our file into the next line variable. So having got our next line, let's increment our patient count variable by 1. Because what we want to do is we want to redeclare our patient dynamic array, but this time we want to start from 1 to our current patient count. So what we're doing is, as we're looping through, as soon as we get the next patient, we increment our patient count by 1, and we redeclare our dynamic array, this time resizing it from 1 to whatever the current patient count is. So the first time we loop, it will go from 1 to 1. So effectively just one position in our dynamic array. The second time, it will go from 1 to 2. The third time from 1 to 3, and so on and so forth until we get to the end of the file. So each time our dynamic array is incremented by 1. Now the key to being able to do this is to make sure we use the preserve keyword. The reason we need this is that when you redeclare a dynamic array, Excel in the background deletes the array and recreates it with the new size. And you lose all the data that you've already put into it. So to tell Excel not to do that, but to actually just increment the size by 1, you need to use the preserve keyword. So having incremented our dynamic array by 1, we can now go to the next position, which will be equivalent to the patient count. And we can set its value to next line. So next line holds our next patient, and the patient count is the next free position that we've just created by redeclaring our array. Next, let's write this to Excel. So we're getting from our dynamic array the position equivalent to the current patient count, and we're writing that to Excel, column A, row equivalent to our patient count. Of course, before we do this, we need to use our Sheets object and make sure we've selected the correct sheet. Finally, we can close our file. Okay. Let's run this code and see what we get. We select our file, we click open, and Excel is populated. And this time, we didn't have to know how many patients we got because we redeclared our array on each iteration of the loop. Next, let's take a look at how we can use the upper bound and lower bound of an array. Now, for a static array, the upper bound and lower bound are decided at the time we declare the array, but we don't know what the upper bound and lower bound are for a dynamic array. Let's see how to work this out and what we can do with that once we work it out. Let's copy this code from our dynamic array with readIm, and let's paste it into our upper and lower bound sub. We'll use the same code and we'll display a message box. Say the lower bound is, and then we'll use the lower bound function and pass in our patient array. Let's display another message box for the upper bound. So what we're doing here, we're opening a file as before. We're using our free file to assign the next file number, and then we use the open method to open the file for input. We then select our data sheet, we set a counter to tell us what patient number we're working with, and then we use a do loop to loop through the file till we get to the end of the file. And on each line, we extract the next line and put it into our next line variable. Before we do anything else, we increment our patient count, and then we redeclare our patient array, this time increasing the upper bound to whatever the patient count happens to be. So we started at 0. Before we used it, we incremented it by 1. So the upper bound is now 1. And then into that upper bound, we place the next line. We then enter that into Excel and we loop round again. And we keep doing that till we get to the end of the file, incrementing the patient count by 1, and therefore redeclaring our patient variable. So the upper bound is increasing all the time. Let's run the code and see what we get for the lower bound and upper bound. So I'll select my patient file as before. Excel inserts the information and then tells me my lower bound is 1 and my upper bound is 10. And as you can see, I have 10 patients. Okay, great. So lower bound and upper bound tell us for a dynamic array what the current lower bound and upper bound values are. Let's see how we can make use of this information. Let's comment out this code and let's see a different way of writing this loop. I'm going to redeclare my variable with preserve, and I'm going to set the first value. So I'm going to put the lower bound to 1 and the upper bound to 1. So I have at least one position in my variable. Let's declare another variable to check when we've completed a loop. We'll make that a Boolean and we'll set it to false to start with. Now I'm going to do my do loop. So in my do loop, I'll then increment my array by 1 every time using my upper bound value to work out what the next value of my array should be. So because I've declared my array with at least one position, I don't want to redeclare it on the first loop. So I only want to redimension it on subsequent loops. So if my first loop completed is equal to true, then I want to redeclare again. But this time I want to go from 1 to whatever the current upper bound happens to be. So whatever the current upper bound happens to be plus 1. So what I'm doing here is the first time I loop, I don't want to redeclare my array because I've already set it here. But on all subsequent iterations, I want to redeclare the array. But this time I want to work out whatever the upper bound happens to be plus 1. So I need to make sure before I do anything else, after my first loop, I set that to true. Now I'm ready for my line input. So I input my next line as before into my next line variable. And this time, instead of using the patient count to work out what the upper bound of my patient array is, I'm going to use upper bound. So I want to put my next line into my patient array, but the position I want to put it in is whatever the upper bound happens to be. So, hope this makes sense. This is my patient array. I need to work out what position I want to put the next line is. The position I want to put the next line in is whatever the upper bound of my patient array happens to be. So now I don't need the patient count variable anymore, because each time I loop through, I'll work out what the upper bound happens to be and I'll put my next line into that position. And then as I loop through, if it's not my first time round, I increment the upper bound by 1. Okay. Let's run the code again and see what we get this time. Select my patient file. My lower bound is still 1 and my upper bound is 10. So now the only thing left to do is to write these values out to Excel. Let's use a for loop to do that. We'll say for I is equal to whatever the lower bound happens to be of patient to the upper bound of patients. And now remember to complete my for loop with the next I. And in my loop, I'll use a range object concatenating on the I to the position. And in the value property, I'll insert the ith value in my patient array. So again, we're making use of the lower bound and upper bound values to loop through our array. Let's run the code and see what we get. I select my patient file. It tells me my lower bound is 1, my upper bound is 10, and it writes the values out to Excel. Next, we'll take a look at the split and join functions. The split function takes a long piece of text and converts it into a dynamic array, breaking the text up at whatever marker you've indicated. So if you want it to break up at every comma, it will do that. Or if you want it to break up at semicolons or whatever you indicate where you want the text to be split up, and the split function will split it into an array. The join function does the opposite. It takes an existing array and it joins it up into a long piece of text using whatever separator you indicate. Let's take a look at these in action. So I have here some patients and they're separated using the /. And I want to use my split function to split these up into an array. So let's copy that and let's go back to Excel. So first, let's declare our patient array variable. And let's declare another variable to hold our patient list. And I'll say patient list is equal to, and I'll paste in my string. So I want to now split this string up into this patient array. The split function is very easy to use. You want to assign your variable, your array variable, to split, and then you pass in the text you want to split, in my case patient list, and then you say how you want to split them, and I want to split on the /. So split, what you want to split, and what the separator is. The split function takes care of the redim preserve and takes care of incrementing the upper bound of our patient array. So with that in place, let's see if we can write this to Excel. I'll use my Sheets object and I'll select the Data tab. With that selected, let's select range A1. Now, let's declare a counter to loop through our patient array. I'll use a for loop, and I'll loop from I equals lower bound of patient to upper bound of patient. And what I want to do is set the active cell value. Then I want to offset by 1 row. One row and 0 columns, and I want to select that. So I start off by selecting A1, and I want to loop from my lower bound to my upper bound, setting the value property of the active cell to the content of the ith position of my patient array. And then I want to offset by 1 row and 0 columns. Okay, let's run the code and see what we get. And as before, our data is split up and entered into Excel. Let's set a breakpoint and run that again and see what happens. So my patient list is currently empty. I've now assigned my patients to my patient list. Let's check in the immediate window what the lower bound currently is. And we get an error because our lower bound is not set. We do the same with upper bound. Again, we get an error because our upper bound is not set. Now let's step through and create our patient array. And let's try that again. Lower bound is now 0. Upper bound is 9. So when we use the split function, the lower bound gets initialized at 0. And then because we have 10 patients, our upper bound is 9. We still have 10 elements, But when we were declaring the array ourselves, we always declare the lower bound as 1, and then the upper bound will be the total number of objects in our array. When Excel does it using the split function, it always sets the lower bound to 0. Just something to be mindful of. Now we can see we selected the data sheet, we selected range A1, and then as we loop through, we're assigning the values to Excel. And we end our loop. One thing you may have noticed is that there is space at the front of our patient names. That's because there's space around our separator. Let's see how we can improve this. It's very simple. We just need to use our trim function. Let's run this one more time. And now our data is nice and neat. Next, let's take a look at the join function. As mentioned, the join function converts an array back into a list. So let's declare a variable to hold our list. So I'll declare a variable called new patient list. And then I want to convert our array back into this new patient list. So we'll set the new patient list equal to, and we'll call the join function. We'll pass in the array, and then we'll say how we want to join them. In this case, I'm going to use the pipe symbol. So join, passing in our array, and then saying how we want to join. Next, let's use our active cell object to offset again by 1. Let's set the value property to our new patient list. Okay, so we're using the same code as before to generate our array using our split function. We're writing the array out to Excel, and then we are joining that array back up together into a string and putting it into our new patient list variable. We're offsetting by 1 and writing that out to the value property of the active cell. Let's run the code one more time and see what we get. And as you can see, our array has been converted into a list, this time separated by the pipe symbol. Next, we'll take a look at the array function. Now, the array function can split any comma-separated values into an array. It could be a list of string values separated by commas. It could be a list of numbers. Anything can be split into an array using the array function. Because array function can split anything into an array, when we declare our array to hold the values returned, we must declare them as a variant. For instance, numbers must be declared not as a string or a set of integers, but as a variant. That way, we use our array function to pass in a set of numbers. And Excel will convert these numbers into an array with each value holding one of our numbers. So how can we make use of this? Let's declare a patient variable as an array, and we'll declare it as a variant. So with my patient array declared as a variant, I'm now ready to use my array function to fill my patient array. I'll grab a file with my patient list, and here I have a set of individual patient names as strings, each separated by a comma. I'll copy that, return to Excel, and I'll set my patient array equal to, and I'll use the array function, and I'll pass in my list of individual patients. And my array function would automatically split these out on the comma into my patient array, setting the upper bound of my patient array as it goes along using the redeem and preserve in the background. With that in place, we can copy our code from before and use it to select the datasheet, go to cell A1, and from our lower bound to our upper bound of our patient array, set the active cell value to the ith content of our patient array. So we need to declare our counter variable. Let's run the code and see what we get. And our string, our set of individual strings, is converted into an array and is used to populate Excel. And as before, we're still able to use our join function to join these up again into a new patient list, which we need to declare. Let's run this one more time. And our new patient list is created with our pipe separator. Next, let's take a look at how we can convert an existing range into an array. So we have the range of values that we populated into column A in our last example. Let's see how we can copy these values from this range object into a patient array and then paste that patient array into column C. So as before, because we don't know whether the values in column A are going to be text or numbers or dates or whatever they might be, the array we declare must be declared as a variant. Now let's use our sheet subject to select our data sheet. And let's use our range object to select cell A1. Now the way you can convert a range into an array is to assign your array equal to, and then you just select the range. So here I'm selecting from active cell dot end, going towards the end. So this selection is now in our patient array variable. So with that in place, we can then select range C1 to C10 and set the value equal to our patient array. Okay, let's run the code and see what we get. And as you can see, our array is copied from column A to column C. One little improvement we can make on our code, instead of hard coding the end position in column C, we can use the upper bound function of our patient array. The reason this is better is because we might not know how many entries are in column A. Here we're copying down. We have no idea what the last entry might be. So our upper bound should be equivalent to the last entry. Let's run this one more time. And our code now works, and it's an improvement on what we had before. Next, let's take a look at how to delete items from a static array. Now this works differently to when you delete items from a dynamic array, which we'll look at next. But first, we'll look at static array. Let's copy the code from our static array that we created earlier and reuse it in our new sub. If you remember, we declared a static array by setting the lower and upper bounds and set its data type to string. We set a counter, which we'll use to loop through our array. But first, we populate our array. We put individual patients into individual positions in our patient array. We then select the data sheet and we loop through our patient array, populating Excel. Let's run that and remind ourselves of how it works. So as you can see, our array is populated with our patients. Let's use a message box to display the lower and upper bound. That's our lower bound, and I'll copy that, paste it below, and use the same code for the upper bound. Now, the way you erase items from an array is you use the erase function and you pass it the array. So having erased that, let's check what our upper and lower bounds are. And let's also write the values out to Excel one more time. This time we'll put the values in column B. Okay, so we've populated our array and we're using a message box to display the lower and upper bound. We're erasing that array, and then we're seeing what the upper bound and lower bound are, having erased the array. And then we'll try to write out the values from our array to column B. Let's set a breakpoint and let's run the code and see what we get. So Excel is populated with our patient names, and our lower bound is 1 and our upper bound is 5. And we've hit the breakpoint, which is where we erase the array. Let's step through that. So we've erased the array. Now let's see what the lower bound is. The lower bound is 1. Let's see what the upper bound is. The upper bound is 5. So the key to remember with the static array is that erasing the array does not change the size of the array. Your lower bound and upper bound will still be what they were before you ran the erase. But what about the values in your array? Let's step through and see what we get as we try to write out these values to column B. So we loop through. We're trying to write the values, but you can see nothing is populating out into Excel. And that is because, having erased the array, the values in our array are now set to nothing. They have been completely removed. So with a static array, erase does not change the size of the array. It doesn't change the upper or lower bounds, but it deletes all values from the array. Next, we'll take a look at how to delete items from a dynamic array. Now, as we saw in the last segment, deleting from a static array deletes the items but keeps the size of the array the same. This is different with a dynamic array. Deleting from a dynamic array removes that position from the array, and so it shrinks the size of the array. Let's take a look at how we write the code. Let's copy some lines from our previous function and put it in our dynamic array deletion function, and let's change our array to a dynamic array by removing the upper and lower bounds. Because it's dynamic, before we use it, we need to redim preserve. And because I know at this point that my array will have 5 items, I can redim preserve from position 1 to position 5 and then populate my array. But my array is this time is dynamic because I declared it with empty brackets. Let's copy the code to display message boxes with the upper and lower bound. And let's use a for loop to write this out to Excel. I'm copying my for loop from my previous function and looping from position 1 to position 5 and printing out the values to column A. Now let's erase our array. And let's use message boxes to display the upper and lower bound one more time. So I've declared a dynamic array. I'm reading preserving from 1 to 5 because I know now at this point that I've got 5 patients. And so I've populated my patient array, and then I'm using a message box to display the upper and lower bound. I then print those values out to Excel. I then erase the array, and I use another message box pair to display the upper and lower bound again. Before we run the code, let's remember to use our sheet subject to select the sheet we want. Now let's run the code and see what we get. So our lower bound is 1, our upper bound is 5, and we write the values out to Excel as before. Let's step through the code. We've erased the array. Now our lower bound is no longer valid. We have a subscript out of range error, which tells us that our array has been completely erased. Next, we'll look at two-dimensional arrays. So far, all of the arrays we've looked at have been one-dimensional. We can only use them to store one list of values, such as a list of patients. But what if you wanted to store something like a table? So, for instance, I have here a rota. So I have in column A, a list of clinicians, and in row 1, I have a list of dates. And for each day, I have the rota for each of the clinicians. So let's take a look at how we can store this sort of table in a two-dimensional array. To declare a two-dimensional array, you give the array a name just as before, but this time instead of one range, you declare two ranges. So here I've declared the rota and I've given it 2 dimensions. So the first dimension from 1 to 4 refers to my list of clinicians, and the second dimension from 1 to 5 refers to my list of dates. And so for each pair of clinicians and day, I can store a different value. Let's declare a counter for the clinician and another counter for the day. And now I can use for loops to populate my array. So for staff counter equals to 1 to 4, next staff counter. And inside my staff counter for loop, I can nest my day counter loop. So I'm nesting my day counter loop inside my staff counter loop, and inside my nested loop, I can populate my rota. So for my staff counter, day counter, so when my staff counter is 1 and my day counter is 1, what value do I want to put in? Well, I can get the value from my cells object, and I just need to get the staff counter value and the day counter value property. So when my staff counter equals 1, I actually want the row staff counter plus 1. And when my day counter equals 1, I want the columns day counter plus 1, because my values start on row 2 and column 2. So before we run the code, we must use our sheet subject to select our 2D worksheet. And then we can set a breakpoint and run the code and see what we get. So the first time we step through the code, our day counter is 1 and our staff counter is 1. And so therefore we want the value from row 2, column 2. Let's check what the value of this is in our immediate window. And as expected, it's equal to on call. Let's step through. And the next time we step through, our staff counter is still 1, but our day counter is now 2. So we're getting the value from column 2 plus 1, column 3. And so on and so forth until we get to day counter 5. And the next time we loop through, we go to the outer loop again. And we start with patient 2, column 1. And we get the value from row 2 plus 1, row 3, and column 1 plus 1, column 2. So let's take a look at how we can extract values from our rota array. Say I wanted to know what my shifts was on Friday. Well, in my array, that will be staff counter 1, day counter 5. Let's use a message box to display what my rota is on Friday. So the way to extract the value from our two-dimensional array is to enter both dimensions separated by a comma. So from our duty rota, I want the value that's entered in position 1, 5. So position 1 on the first dimension would equal to the staff counter, and position 5 in the second dimension will equal to the day counter. Let's run this code and see what we get. And it says, my duty on Friday is on call, as we can see there. Let's try another consultant. Let's find out what Dr. Khan's rota is. Dr. Khan is in position 3, and we want to know what they're doing on Thursday. So position 3, day 5. Let's run the code and see what we get. And as expected, we get study leave. So for one-dimensional array, we enter 1 value in our brackets, but for two-dimensional arrays, we enter 2 values separated by a comma. So in this segment, we've taken a look at one of the most powerful features in Excel VBA programming, the use of arrays. We've learned the difference between static and dynamic arrays and the power of declaring a dynamic array when you don't know the size of the array that you will eventually need. When you're working with dynamic arrays, you need to be able to redeclare the array so that you can increase its size as your list of items you want to include increases. But then having done that, you want to be able to work out what the upper and lower bounds are. We've taken a look at 2 different ways to create arrays from lists. One is using the split function, and the other one is using the array function. A third way of creating an array from a list is to convert an Excel range into an array. We've looked at what happens when you delete from a static array as opposed to when you delete from a dynamic array. And we've had a brief look at multi-dimensional arrays in our example, limited to 2 dimensions, but you can go to n dimensions. So I hope you found that interesting and useful, and I will see you in the next video.